In football, outstanding shooting performance is characterized by highly effective and efficient movements. It is well accepted that sufficient visual gaze behavior is required for prospective control of movement and appropriate goal-directed actions. Within closed motor skills in football, most research on visual gaze has been focused on the goalkeeper. A study revealed the gaze behavior in a more dynamic condition, that is of the penalty taker. They found that gaze behavior prior to the run-up is essential for accurate shooting performance. The final fixation prior to the onset of the movement is called quiet eye. There is a lack of evidence on visual gaze behavior in other football-specific aiming tasks, such as free kicks. Based on the aforementioned findings, it is expected that performance in other football shooting conditions will also be related to specific visual gaze behavior. Therefore, in the current study, it is hypothesized that there is a relationship between free kick shooting accuracy and visual gaze characteristics, in particular, the quiet eye duration. Method. 14 skilled youth, mean age 15, football players, participated within their usual training time. The experiments were conducted on an artificial grass pitch within the Sports Science Center, AFC Ajax. A standard free kick practice wall with 5 removable dummies was used in the test. The wall was placed between the ball and the goal at a distance of 15 meters from the ball, aligned with the center of the goal. The eye tracking device used was the ASL mobile eye. The eye camera captures the right eye of the player, while the scene camera records the environment in front of the player. Both image streams are recorded on the same digital medium by alternating frames. To gain insight into the relationship between gaze behavior and accuracy of shooting, a shooting task with a controllable setup was designed. The target task was chosen to be challenging but also suited to the skill level of the participants. Each player was challenged to shoot at the predefined target area 10 times while his gaze behavior was being tracked. Each time 6 trials were taken from 18 meters. In the current study, there was no goalkeeper included to keep the setup controllable and not influence the player's gaze behavior. To exclude influence of a preferred side, the shot was taken from a position in line with the center of the goal. Players with right leg preference took 10 trials aiming at the right half of the goal. Players with left leg preference took 10 trials aiming at the left half. Instructions. The players first received information about the shooting task and the mobile eye device. They were instructed to shoot the ball into the right or left upper half, corner, of the goal. No instructions were given on how the ball should be kicked, instructed on where to look. Data analysis, parameters. Accuracy. For the analysis of shooting accuracy, the number of goals, accurate shots, within the defined target was divided by the total number of trials per player. Gaze behavior. To gain more insight into the gaze behavior, for dependent variables, number of fixations on target, fixation duration, fixation location, and fixation sequence, were assessed. The onset of each trial was defined as an arbitrary 3 seconds before ball contact, capturing all locomotive phases. The fixation duration per location was determined, and the number of fixations was calculated for each trial and then averaged for each participant. The results were coupled with the corresponding phases of the locomotor behavior, shooting action. Results. Accuracy performance. The test design was sensitive to shooting accuracy with a variance between 30% and 80% and allowed the researcher to distinguish the more accurate, good, performers from the less accurate, poor, performers. Quiet eye characteristics. The mean quiet eye duration on target, the fixation duration on the ball and the number of fixations on the target are displayed per player in the table. Good versus poor performers. Parametric independent t-tests were performed for the following results. The accuracy score. There was a significant difference in the accuracy score. Locomotion. Individual players differed in the time they needed to perform the shooting task. Therefore, the gaze behavior of each individual phase was evaluated to identify certain gaze sequences. Comparing players based on performance. Accuracy score per player was used to rank the players. To distinguish the better shooters from the less accurate players, The group was split in two with a cutoff point of 50% accurate trials. The better performers were statistically compared to their less accurate teammates. Dependent t-tests were performed on accuracy score, mean fixation at target, mean fixation at ball, and mean number of fixations. Comparing trials based on outcome. To analyze the relationship between accuracy and visual gaze, all trials are distinguished by hit or miss. The fixation duration at the target. The mean quiet target durations between the good performers and the poor performers were not significantly different. The number of fixations. The difference between the mean numbers of fixations of the good performers and the poor performers was not significant. The fixation duration at ball. Comparing the fixation duration at the ball between the good performers and the poor performers using an independent sample t-test revealed a significant difference. Scored versus missed trials. Effect of outcome. Significant differences were found for outcome and also quiet allocation. Outcome of the trials differed. Effect of the quiet allocation on the outcome is less, but significant. Therefore, the researcher looked at both quiet allocation separately. Quiet eye duration at target. The figure illustrates the distribution and difference for all trials, those in which the player scored and those in which the player missed. It can be clearly seen in the figure that for the scored trials, the player had a longer fixation on the target prior to ball contact than in the missed trials. Fixation duration at ball. The fixation at the ball was also longer in the scored trials compared with the missed trials. The quiet eye ball duration in the scored trials did significantly differ from that in the missed trials. The number of fixations. The number of fixations was defined as the number of times that a player fixated his gaze on the target for a minimum of 125 milliseconds consecutively in the 3 seconds prior to ball contact. Some players did not look at the target at all and some looked 3 times. Players who fixated on the target location once scored most. The difference within players between scored and missed trials. The figure visualizes the difference between quiet eye duration in scored and missed trials for each player separately. Their mean quiet eye duration was significantly longer prior to the scored trials than prior to the missed trials.